Hello friends, in this topic I am just going to show you what are the different data types which are used in C programming. So what are the data types? Suppose the data types can represent different types of information. In the case of C programming, by means of data types we can represent different types of variables or any sort of information of a particular type. So data types are used for expressing different types of information in the C language scenario. So basically data types can be of 4 types which are commonly used in C programming language. The data types can be like this. If we just classify the data types in a schematic way, data types can be classified as integer data type, float data type, character data type, and double data type. So integer data type is something which represents integer values. Suppose integer variables can be taken like this. It has a short form. It has a short form of int. We write the integer variables. When we declare integer variables, we write int before that. For float, we write float. There is no short form for float. For character, we have a short form, char. For double, we have to write double. So, suppose we write int a is equal to 5. So this 5 is being assigned to this variable a, or the keyword which depicts a variable a, which is an integer data type variable. So 5 is an integer which can be assigned to an integer variable. So this sort of variable, this sort of values 5, 10, 15 or something like that can be taken to be an integer variable. So this can be considered to be an integer data type. So integer data type have, in terms of size, in terms of bytes or bits, you can say the size of integer variable is, in memory it takes about 2 bytes of memory. That is, integer variable always takes 2 bytes of memory. So in terms of bytes, it is 2 bytes or 16 bits of memory. So in terms of size, integer data type contains, it can occupy 2 bytes or 16 bits. In the case of float variable is something which can take expressions like this. We can write like this: float b is equal to 2.56 or something like this. Anything which can contain a fractional part of the decimal point can be taken to be a float variable. So float variables can be like this, and float variable has in terms of bytes or bits, in terms of size which is occupied, in terms of memory representation, float can take 4 bytes. It can occupy, rather it will occupy 4 bytes, that is 4 into 8, that is 32 bits of memory. So integer occupies 16 bits or 2 bytes of memory, float occupies 32 bits or 4 bytes of memory, and then comes the character data type, which can be written in this manner. That is, if we define a character variable and I have to put a character constant inside it, I have to assign a character constant inside the character variable. Otherwise we cannot assign anything other than characters in a character variable or a character data type variable. Like if I write like this, char ch is equal to capital X. So you can we can write char c is equal to, suppose we can write 2 over here. So this X, this capital X is enclosed in single quotes this 2 is enclosed in single quotes. So these are character constants which can be easily assigned to character variables or variables of character data type. So this is an example of, this is an entire example of character data type declaration and initialization. This is an example, this is also an example of that character data type variable declaration and initialization. So character variable in terms of memory, it occupies 1 byte of memory. Character data type occupies 1 byte of memory, that is 8 bits of memory. So in terms of character, in terms of memory representation or occupation of memory in terms of bytes or bits, character data type takes 1 byte of memory, or it occupies 8 bits of memory. So now we come to the last data type, that is double. And double is something which can hold fractional values, but which are supposedly the higher version of this float. So double can contain larger decimal values or values with fractional part which are very large values, so that with the values which cannot be accommodated by this float data type can be accommodated by double data type, because float data type has an occupation in terms of memory of how much? 4 bytes. So, but this double is just the double of that. That is, double will always occupy 8 bytes of memory. So it can accommodate larger values. Float values of larger dimensions can be accommodated in double. They cannot be accommodated in the float because it can only be a 32-bit representation. It is a 4-byte representation. So a 32-bit representation or 4-byte representation can hold up to that, and beyond that, if we have to represent any other values of very high dimension, we can accommodate those values in this double data type, which can accommodate rather in terms of bytes, 8 bytes. That is just the double of this 4. So that is the reason why it is called double. And this 32 bits become also double, that is 8 into 8, 64 bits. So this is the occupation of memory in terms of bytes or bits in case of double data type. So suppose we can also include another data type which is not included in the basic 4 data types of which are used in the C programming scenario. There is yet another data type which is incorporated in this entire list of data types, which is incorporated in these lists in some textbooks, and it is not also included in other textbooks. So if I just mention that and add it to the list of these 4 basic data types, there is a data type which we can also consider to be one of these basic data types is this void, which is nothing but a data type having no values, or it is something which doesn't express any particular type of data. When there is nothing to represent in terms of data types, we can use this as the data type void, as we can write, if we don't have to return any values from a function, then we can write void function name and argument list, something like this in the prototype or in the function definition. Suppose let it be a function definition. So we'll write some expression statements over here, void function name argument list, and then in that case, why we have written this void? Because there should be a return type in case of any function definition. So if there is nothing is to be returned from the function, then we are going to write this void in the return type section. That is, the data type which is to be returned is taken to be a void data type. We can write in Turbo C++, we are very much acquainted with writing the main section like this, void main, because void main didn't return any sort of values after the code has been written. So return 0 is not needed in this sort of writing programming in C. So void main is nothing but it is not returning value. Since it is not returning value, the main function is not going to return the value. So in that case, we have to write void in those cases where there are no return types to be specified. So main is not returning any sort of values. So return 0 is not needed. So expression statement, last we write the get ch statement and then come to the closing brace, and due to this get ch is included in another file inclusion directive which is called #include conio.h directive. I will just discuss it later on. So that is a different way of writing C programming. So we are following the int main pattern of writing the programming and returning 0 after writing the before finishing of the main section. So in that case, where we write this void main type of programming, we use this void as a data type. So void can be considered to be a valid data type in the set of these data types. So if you have any doubts or queries pertaining to this explanation or this video, you can just post your doubts or queries in the comment section below so that I can address them. Thanks for watching my video.